The first binomial formula. Let's start with an explanation of binomial formulas. So, what are binomial formulas? Binomial is derived from bi, two, and nouns, names. What do you need binomial formulas for? The three binomial formulas are needed in the following places. They help you calculate the square of brackets. You can use them to undo the multiplication, i.e. create brackets again. They help you transform certain equations. A plus b squared equals a plus b equals a squared plus 2ab plus b squared. How do you get the binomial formulas? You can look at the binomial equations graphically or mathematically, but since we want to use these in the examples, we'll use the mathematical version here. You get the equations from above which you multiply. The binomial formulas, which are very important in algebra, are used to simplify expressions, especially expressions with two-term terms such as open parenthesis a plus b close parenthesis to the power of n, where a and b are arbitrary numbers and n is an integer. There are three binomial formulas. 1. The first binomial formula, a plus b squared equals a squared plus 2ab plus b squared. 2. The second binomial formula, a minus b squared equals a squared 2ab plus b squared. 3. The product formula, a plus b, a minus b, equals a squared minus b squared. These formulas are extremely useful for developing quadratic terms and simplifying expressions that contain binomial terms. The first binomial formula, a plus b, squared states that the square of the sum of two terms, a and b, is equal to the square of the first term, a squared, plus twice the product of the two terms, 2ab, plus the square of the second term, b squared. Example. 3x plus 4, squared. 3x, squared plus 2 times 3x times 4 plus 4 squared. Results in 9x squared plus 24x plus 16. The formula is derived by multiplying out the brackets, with the binomial formulas making this step easier. When two identical brackets are multiplied together, the binomial formula is obtained, a plus b squared equals a plus b equals a squared plus 2ab plus b squared. The second binomial law is a minus b squared equals a squared minus 2ab plus b squared. This law describes the expansion of a binomial expression, i.e. a sum or difference of two terms, to the square. To understand this better, let's look at a few simple examples. Example 1, x minus 3, squared. 1. Identify a and b. A equals x. B equals 3. 2. Apply the second binomial law. X minus 3, squared equals x squared minus 2 times x times 3 plus 3 squared. 3. Evaluate the terms. X squared minus 2 times x times 3 plus 3 squared equals x squared minus 6x plus 9. This gives x minus 3 squared equals x squared minus 6x plus 9. Example 2, 2y minus 5, squared. 1. Identify a and b. A equals 2y. B equals 5. 2. Apply the second binomial law. 2y minus 5 squared equals 2y squared minus 2 times 2y times 5 plus 5 squared. 3. Evaluate the terms. 2y squared minus 2 times 2y times 5 plus 5 squared equals 4y squared minus 20y plus 25. So we get 2y minus 5 squared equals 4y squared minus 20y plus 25. Example 3, a minus b squared. 1. Identify a and b. A equals a. B equals b. 2. Apply the second binomial law. A minus b squared equals a squared minus 2ab plus b squared. This shows that the law is generally valid for any terms a and b. Summary. The second binomial law helps us easily calculate the squares of differences between two terms. It is a minus b squared equals a squared minus 2ab plus b squared. To use it, you need to 1. Identify the terms a and b. 2. Apply the law. 3. Calculate the resulting terms. This makes it easier to expand expressions like a minus b squared without having to perform each step manually.
Third binomial law. The third binomial law states a minus bb2 a2 minus 2ab plus b2. This means that if we want to calculate the square of the difference between two terms a and b, we use this formula. Example, suppose we want to calculate x minus 3, 2. First, we apply the third binomial law, x minus 3, 2, stacks x2 minus 2 times x times 3 plus 32. Now we multiply the terms out, stacks x2 minus 6x plus 9. Therefore, x minus 3.2, x2 minus 6x plus 9. Understanding, x2 is the square of the first term x. Minus 6x is created by doubling the product of x and 3. So 2 times x times 3, 9 is the square of the second term minus 3. The third binomial law is therefore a useful rule for quickly calculating the square of the difference of two terms by multiplying the terms in pairs and then adding them. And examples. Example 1, calculate 2x minus 5.2, applying the third binomial law, 2x minus 5.2, 2x 2 minus 2, times 2x times 5 plus minus 5.2, multiplying out the terms, 0.42 minus 20x plus 25, therefore 2x minus 5.2, ser 42 minus 20x plus 25.
Example 2. Calculate 3y minus 4.2, applying the third binomial law, 3y minus 4.2, 3y 2 minus 2 times 3y times 4 plus minus 4.2, multiplying out the terms, I 9y2 minus 24y plus
16, therefore 3y minus 4.2, 9y2 minus 24y plus 16. Example 3, calculate a minus b on 2, applying the third binomial law, a minus b on 2, a2 minus 2ab plus b2, where a and b are any variables or constants. Example 4, calculate x2 minus 2.2, applying the third binomial law, x2 minus 2.2, x2.2 minus 2 times x2 times 2 x 2, multiplying out the terms as x4 minus 4 x 2 plus 4, therefore x2 minus 2.2, x4 minus 4 x 2 plus 4. Summary. The third binomial law is a useful rule in algebra to quickly calculate the square of the difference between two terms. The formula follows a minus b2, a2 minus 2ab plus b2. Using this formula, one can efficiently calculate the square of a difference by multiplying the terms pairwise and then adding them.